industrial measurement control loop. In that, the first experiment is simulation study of PLC. First, let us see the introduction to PLC. Introduction to PLC. What is relay? Relay is nothing but a switch, electromechanical switch. Relay is electromechanical switch. I think you used in process control lab for on-off control. That is called a relay, you know. But that is old style. That is old technology. But nowadays, what is available? Solid state switches are available. Even for higher current, solid state switches are available. So in place of relay, we can use solid state switches you can use. What is solid state switches? Electronic, pure electronic, power electronic switches. If you give one signal, it will turn on. If you give 0 signal, it will turn off, like that. So it is called solid state switches nowadays available. But to understand PLC, we have to take this electromechanical switch. The electromechanical switch. The electromechanical switches in the olden days, before invention of microcontroller, electromechanical switches are used to control electrical circuits. That we will see now how it works. Even now it is used in on-off control of motor. Even now that type of switches are available now for on-off control of induction motors. The DOL starters are available. Here, before going that introduction, what is PLC? Programmable logic controller. In other words, we can call it as a embedded system. It is embedded system. It is a programmable electronic device. So it is the embedded system. It consists of both hardware as well as software. This is start switch. This is stop switch. And the end, there will be a relay. Relay, other end is connected to neutral. This end is connected to phase. This relay will work on 230 volt. This relay will work on 230 volt, let us assume. But it is going to handle higher voltage, higher current than 230 volt. So this relay will handle high voltage, high current to turn on a motor, say high capacity motor. This is going to handle. How we can start? If you press this, what will happen? Phase is connected to this coil and the other end is connected to neutral. That's why this will energize, the motor will run. But what you have to do is continuously you have to press the start button. If you press, then it is connected. Am I correct or not? If you press, the circuit is closed. That's why this motor will continuously on. If you release this, this is called push button. This is called push button. This is also called push button. Push button is like calling bell switch. If you press, it will be closed. If you release, it will be open. So the start button is like push button. It is a push button. That's why if you continuously press, the motor will run. If you release it, motor will be turned off. You can do jogging only. Jogging means if you want to do some pushing work in earth moving vehicles, they will do jogging. Jogging means just push. For temporarily, it will push. Temporarily, the motor will be run. That for that work, you can use this. If you press that start button, motor will run. If you release it, motor will be turned off. That is called jogging. You can use 5 times a minute. The allowable limit is 5 times a minute. You can turn on and off. But continuously you want to run the motor means you need this switch must be closed. For that, I can put one more parallel switch here. Parallel switch here. Parallel switch here like this. Let us assume that this is switch. If the switch is, if I press start, this also closed means after that, even if I release, the motor will continuously run. Am I correct or not? So this can be connected across this also. Another one more contact is there. 2 contact relay, let us assume. It is a 2 contact relay. This is A, B. A, B is for motor. C, D for this. Here you connected C and D. You connected C and D here. Am I correct or not? If you press this, if you push the start button, what will happen? Both contacts will be closed because it has 2 contacts. That relay has 2 contacts. One for motor, another one is just for low current, low voltage. So that CD is connected here. What will happen if I press start? Both contacts will be closed. That's why the power will go through. The power will go through this way. The power will go through this way. Am I correct or not? Because CD is connected here. CD is already closed there. Because of start button, CD is closed there. That's why this, even I release the start button, the motor will continuously run. So that's why this button is called start button. It is only used to start, that's all. If you press, it will be started, then continuously the motor will run. That's why this CD contact is called sealing contact. It seals the circuit. That's why it is called sealing contact. How to stop? I want to stop the motor. Another push button that always closed. Another push button. This push button is X0. This push button is, let us call it as X1. X1 is always closed. That is also in series with that. If I press that temporarily, that push button, what will happen? Circuit will open. The coil will de-energize. Motor will be turned off. CD also will be disconnected. CD also will be disconnected. That's why this also will be disconnected. That's why there is no power, continuous power. That's why relay will be turned off. Motor will be turned off. Again, how to turn on? If you press the start button, motor will be turned on. This type of circuits are used in electrical. Suppose you want to do 2-3 sequence of operation means they will put another circuit. This is called they want to do 2-3 operations they want to do. Then what they will do, you know, they will put one more circuit here. One more circuit like this. One more circuit for some other operation. That some other operation may be a heater, another may be lamp, another may be another motor, another may be a stirrer. Like that, they will add so many. If you look at this circuit, it looks like ladder. Why? The circuit is one side phase, another side neutral. Circuit is like this. First circuit, second circuit, third circuit, fourth circuit. It looks like ladder. That's why this type of programming, this type of circuit is called ladder logic circuit. That's why it is called a ladder. It looking like ladder. That's why ladder logic circuit. After invention of, this is older system, before 1970s, before invention of microcontroller. But after that, after invention of microcontroller, embedded system came into picture, PLC came into picture. But the already some engineer, those who are working for 15-20 years, they cannot write a program for embedded system because they have to write CR. They have to write in CR. Those days, sometimes COBOL, basic like that programs were there. They do not know the programming. They won't believe first. In industry, first thing is reliability. First thing is reliability. Why? There is no reliability means you cannot run the factory continuously. The factory get into loss. That's why reliability is more important. That's why the embedded system programmer, the embedded system designer introduced the ladder logic program. If the program is looking like the same circuit, then they will accept. Do you understand that? If they write the program like circuit, they will understand that, they will accept the new invention. Otherwise, they won't accept it. They will use the old one only. They will use the old one only. You cannot introduce a marketing strategy. So to market, that too, the existing engineer can understand this. You need a programming like ladder logic. You need a programming like ladder logic. That's all. So the program is looking like this. We can, if the circuit can be easily converted into the program. Any circuit like this can be easily converted into program. That's why the ladder logic program came. Before writing ladder logic program for the same motor starting program, let us see what is PLC. How it looks like, that we will see now. PLC is nothing but an embedded system. Already I told you. Embedded system means what will be there? Definitely there will be a microcontroller or microprocessor will be there. A processor will be central, CPU will be there. Definitely CPU will be there. If CPU is there, definitely memory will be there. Memory will be there. There are 3 memories I marked there. One for read-only memory and random access memory. This is for programming and BIOS. What is BIOS? Basic input-output system. Basic input-output system. What is BIOS? Anybody else? Any embedded system, it requires BIOS. A computer has BIOS. BIOS memory is there. That's why it knows where to load the program. Windows is loaded from the memory. When you turn on, automatically the BIOS will run. BIOS program in the read-only memory will run and access the hard disk and load the Windows program into the memory. Basic input-output system that knows where keyboard is there, where hard disk is there, where memory is there, that and all. It knows minimum program. That loads the program, then it takes care. So for that RAM, read-only memory and the random access memory will be there. This is for temporary calculations, you know. In addition, there will be input image table. Input image table. Image table. Output image table will be there. Output image table will be there. The input image table is whatever input you are giving, that will be stored in terms of zeros and ones. On means it will store as 1. Off means it will store as 0. Like that. Input image table is nothing but a memory. It has input values. Output image table is also zeros and ones. It has zeros and 1 again. If a device is turned on, it will have in a memory location, it will have 1. If a device is turned off, it will have a 0. That's all. Input image, output image table has output values. That's all. This part is electronics. You know, it is nothing but a embedded system. PLC means one more is there. That is input module. Input module will be there. Similarly, there will be an output module will be there. Output module will be there. What the input module will do, you know, it needs input. Suppose I want to start means I will press a push button. So he is giving 1, logic 1. Like that it will read and it will put that value in the image table. That's all. The working of input module is, it read the input, whatever input we are giving, it will put it in the input image table. That's all. The output image table, what it will do, suppose I want to run a motor here. I want to run a motor here means the output image table, the motor in a particular location, motor data is stored. That one will be sent here to turn on the motor. Here it may be 5 volt to tell it is logic 1. That 5 volt output module will convert this into 230 volt or 440 volt. Some relay will be there, some devices will be there. That is none of our business. That will turn on the motor. Or another relay that will turn on the motor. Do you understand this? As far as we concerned, we will see the input signal as zeros and ones. Output signal also as zeros and ones. That's all. If you want to write a program, you have to see input signal as zeros and ones. Output signal also zeros and ones. If it is 1 means the device will be turned on by the output module. It will be designed by the PLC manufacturer. Why you are worrying? If you give logic 1 as output, the device will be turned on because the output module is designed for 230 volt. But inside it is an embedded system. For that, you need logics, zeros and ones as inputs, zeros and ones as output. That's all. Now, how it works? So, it depends upon zeros and ones. The output devices connected here will be turned on and off. Depends upon the zeros and ones coming here, the program will take care of those input values. Depends upon that, it will turn on and off the output devices. Do you understand that? Now, you have to write a program for this part. That is called ladder logic program. That is called ladder logic program. That has to be loaded into this embedded system. So how this PLC will work? If you turn on the PLC, what it will do is, it will read the input image table, because input module will put all its data in the input image table. So the program is written such a way that the BIOS, basic input output program, the OS, the operating system of PLC, what it will do is, it will read the input image table, run the program, update the output image table. Again, it will read the input image table, run the program, update the output image table. Again and again, it will do the same thing. That's all. If you turn on a PLC, it means it read the input values, run the program, update the output values. Read the input values, run the program, update the output values. Again and again, it will do the same thing. But there is some difference between this type of executing the program and the relay logic that we have seen earlier. There is a small difference is that we should understand. As an instrumentation engineer, we must understand. Otherwise, our program may do some harm to the device or man. That's why we should understand. For that, the third experiment is alarm management and programming a PLC for lamp control using single push button. If you understand that program, you can understand how PLC works, so that you will not do such mistakes in your program. That's all. So this is to understand working of PLC. The third experiment is to understand how PLC works. That's all. Why we need only one push button to turn on a lamp? If you press one time, that lamp will be turned on. If you press again the same push button, lamp will be turned off. So it works like toggle switch. If you press once, lamp will be turned on. You can write a program for that. So by writing program for that, we can understand the behavior of PLC. For that, the third program. Now we will write a ladder logic program for this same start, stop, a motor and a ceiling contact. How to write a ladder logic program? If you write a ladder logic program, that can be compiled. Once it is compiled, it is like a machine language. It is like machine language, like what you wrote for 8085 or microcontroller. 8051 you wrote, like that it will be. It will be loaded into the embedded system. It will be loaded into the embedded system once it is compiled. But you can write in the front end, I want to run a motor by using PLC. First, what I have to do is, I have to connect a push button in the input module. I have to connect a push button in the input module. Let us assume that it is connected to the memory location X0. The hardware device is named as 5 volt. Here 5 volt is available in the input module, that is taken and it is connected in the X0. In the input module, a memory location is called X0. If I temporarily press it, momentarily it becomes 1. Momentarily it becomes 1. If I press that, because 5 volt, you know, if I press that, momentarily X0 becomes 1. X0 becomes 1. So this 1 will be read by the program. Based on the PLC program, it will update the output image table Y0 equal to 1. Y0 equal to 1. For that, we have to write a program. Suppose I want to turn off the motor, means another push button is available. That is connected to X1 in the image table. This this is also connected to that 5 volt. This is always on. This is stop button. This push button is always closed. If I press it, will open. If I press it, will open. If I press it, will open. This is stop button, this is start button. The hardware is, these two hardwares are required in both cases. In relay logic method, as well as here, you need start button, stop, start push button, as well as stop push button is required. So in the output side, Y0 is connected to the motor. That's all. Y0 is directly connected to motor. Here 230 volt is available. This neutral also available. So motor will turn on. If I press start button, motor will be turned on. For that, we have to write the program. The program is looking like relay logic circuit. For that, we will draw phase line and neutral line. Here we won't say it is phase line, neutral line, but a line will be there while writing that program. We can assume that it is phase or +5 and ground, like that you can assume. Here I need a push button, start button. This push button is start, or I can call it as X0. I won't write hereafter start push button. Instead, I'll simply put X0, because start button is where connected. X0. That's why simply I can say that it is X0. If I press, it becomes, you can think it is like a buffer. If you give 1, it will give 1. If you give 0, it will give 0. It is like buffer. So this switch will become 1. This will become 1. So this 5 volt will pass through this. Our phase will pass through this. Another circuit I'm having, this is called normally closed contact. This contact is called normally open contact. This is called normally open contact, NOC, normally open contact. This is normally closed contact. Here it is like NOT gate. It is like NOT gate. For that, if I put like this, this stop button will not work out. This stop button will not work out, because if you give 1, it becomes 0. If you give 0, it becomes 1. Because it's permanently it gives 1. That's why what will happen here? It becomes 0. Logic 0. Or this becomes open. This is normally closed. This becomes open. Open means what? Switch is opened. You think like switch. This switch is normally open. If I give logic 1, it is closed, first switch. Second switch normally closed. If you give 1, it will open. That's why you cannot use this. That's why what I will do is I will put normally open again. It means this is always closed. Stop button is always closed. That's why this is also will be 1. Am I correct or not? Have you understand this? Have you understand this point? Because always 1. Stop button is always closed. That's why this is also 1. This is also 1. 5 volt is available on the other end. Now I can connect a relay here. Relay will be marked like this. That's all. The relay will be turned on. The relay will be connected to motor. Here in this case, it is connected to Y0. This is connected to X1. This is connected to X0. That's all. It will work. It will work. But again, the same problem. If I press start button, it will run. If I release start button, it won't work. You understand this? But the output image table, what is the name of the variable? Why not? The output image table, what is the output? Why not? The same can be used as input. Because it is also memory, no? Some value stored at Y0. It can be used as input also. Because it is a memory. Y0 is a value. Logic 1 is stored at Y0. That's all. So I can put like this. I can put like this. I can put one more contact. These are all soft contact, not hardware. This software. Soft contact. I am named it as Y0. That's all. The same program written like this through software. Here, if I press start button, motor will be turned on and remain turned on. Because Y0 is in parallel with X0. Y0 is in parallel. You can use n number of Y0. Memory can be used any number of times. While writing program, suppose you are declaring a variable X means any number of times you can use that variable. Y0 also variable. That's why you can use any number of times. So you can put Y0 here. That's all. So if you press X0 start button, X0 becomes 1, temporarily 1. Because of that 1, already X1 is 1 because it is permanently closed. That's why this is ground. This is plus 5 volt. This is plus 5 volt. Or you can assume as this is a phase. This is neutral. That's why relay will be turned on. The motor will be turned on. Motor will be turned on and remains turned on. Why? Y0 is in parallel with X0. Y0 is in parallel with X0. That's why it remain on. Suppose now I want, this is available in the software. This is available in the store. You can pick this and place. You can pick this and place. You can pick this and place and connect. Then compile, upload. That's all. Then PLC will run this program. PLC will run this. Already I told you that if you load some program, the PLC will run forever. If you turn on the PLC, always it will run the program. Always it will run the program. You cannot stop it. If you turn on a PLC, always whatever the program available inside the PLC, it will always run. So if you press the start button, once you loaded this program, and if you connect, if you do the connections like this, if you do the connections, like this, and if you load the program into that embedded system, that PLC, if you press the start button, the motor will run. The motor will run. So that's why this is called programmable logic controller. Your logic is working by programming. That's why programmable logic controller. Write a PLC program for turning on and off of a staircase lamp. Staircase lamp using ladder logic. Using ladder logic. So we have to write program to turn on and off a staircase lamp. Staircase lamp, how it works? Or lamp will be on the staircase. You can turn on the lamp off by using 2 switches. Suppose you are in the ground floor, means you can toggle the switch, the lamp will glow. the lamp will glow. You can turn off here in the first floor. That is called staircase switch. How to write a PLC program to turn on and off from two different places. So two switches will be there. Two switches will be there. One will be in the ground floor, another one will be in the first floor. Let us assume it is connected to the PLC. The lamp has to be controlled. The lamp has to be controlled. That's all. So what is, while writing a PLC program, you should be very thorough in digital electronics. Then only you can easily write the program. Here, what is the logic? Let us assume that here on, off, two states are there. Logic 1, logic 0. Here, on, off. Suppose here it is in on state, lamp will glow. Am I correct or not? Here it is in off state. Here it is in on state. That's why lamp is glowing. If you come here also if you put in on state, lamp will be turned off. Am I correct or not? Staircase switch will be like that. Here it is turned on, there it is off. There also if you turn on, turned off. So logic will be like this. Logic will be x0, x1, two inputs. Y0 will be 1. If this is 1 and this is 0 means lamp will glow. If I change this also 1, lamp will be turned off. Am I correct or not? Suppose I am coming, again another person coming from ground floor, he makes off, but it is on. Still first floor is on. That's why it will be turned on. Suppose again he is coming to the same person now coming to the first floor, the second person coming to the first floor and he is also making off. That's why lamp will be turned off. What is that logic? R. XOR gate. So we have to write a logic in a ladder logic program for XOR gate. That's all. AND logic means this is AND logic. This switch is closed. This switch also closed. Then lamp will be turned on. Let us assume that this is lamp. This is switch 1, switch 2. If both are turned on, lamp will be closed. Lamp will be turned on. Am I correct or not? This circuit is called R. Already we have seen R logic. If this is on, or this is on, lamp will be turned on. Am I correct or not? So if you put two switches in parallel, then it is called R logic. Two switches in parallel, this is called R logic. You have to write a program for XOR logic. What is the expression for XOR logic? Let us assume that these two are AB. AB and Y. What is the logic? AB bar plus A bar B. A bar B. That is equal to Y. You can easily write the program. If you know the logic for XOR gate, then you can easily write the program. These two are AND logic. Am I correct or not? AND but B bar. It means you have to use normally closed. B bar means normally closed. It is like NOT gate. Bar means NOT gate. B bar means, already you know, bar means NOT gate. So normally closed contact if you use, that's all. A and B bar are in series. A, B bar are in series. A and B bar. A and B bar in series. Plus means what? Parallel. Again A bar and B are in parallel. That's all. This is the program for ladder logic, for staircase. That's all. Now let us check. Instead of AB, let us put X0. Because in the programming, we have to use X0, X1, X2, X3. That's why we'll practice instead of AB, let us prove you practice X0, X1, X2. This is X0. This is X1 bar. This is X1 bar. This is X0. Sorry. X0 bar. This is X1. That's all. Let us check whether it is working or not. Let us check. Here, what is the connection diagram? Connection diagram in the input module. Connection diagram in the input module. X0 is connected to the toggle switch, not push button. Toggle switch means we would put like this. Toggle switch means if you close, it remains closed. Remain close. If you close, remain, it becomes 1. It remains 1. So I am putting a toggle switch. One is called not push button. For this function, you need a toggle switch. Now, both are open. Both are open. Both are 0. Both are 0 means X0 equal to what? 0. X1 equal to what? 1. Am I correct or not? Two switches are in series. One switch is closed, another switch open. There is no power. Come to the second line. Here if we come, X0 is open. That's why this is 1. X0 bar. But X1 is what? Again it is open. That's why there is no power. That's why lamp is off. Am I correct or not? Now, this is state 1. This is state 1. The state 2 is state 2. This is in ground floor. This is in first floor. Both are in off state. Let us assume. Now, this is X0. This is closed. And this is open. Now, he is in the ground floor. That's why this is closed. Now, lamp is, let us check whether lamp is glowing or not. X0 is 1, you know. X0 is 1. X1 bar also 1 because X1 is open. That's why that is also 1. Already I told you that if it is normally open, normally closed contact means if you give 0, it becomes 1. If you give 1, it becomes 0. So both are 1. That's why this lamp will be turned on. The lamp will be on. Am I correct or not? Now he reached the first floor. What he will do? He will close He will close X1. He will close X1. Am I correct or not? This is state 2. This is state 2. State 3. In state 3, he reached the first floor. That's why already he closed in the ground floor. Now he is going to close in the first floor also. This is X1. This is X0. Both are 1. That's why what happens in the program, X0 is 1, but X1 bar becomes 0. X1 bar becomes 0. That's why it is not working. The lamp will be turned off. Lamp will be turned off. Am I correct or not? The lamp is connected to Y0. You don't put L in the program. Put Y0. Now, another person is coming. That way only we assumed. Another person coming to the ground floor. What he will do? State 4. State 4. He will open the switch. He will open the switch. But already in the first floor, it is closed. This is X1. Already this is closed. X0 is now he opened by the second person. Now what will happen? X0 is 0. Therefore, X0 is 0. Here, X0 is 0. X0 equal to 0. X1 already closed. That is also 0. Here, X0 bar, X0 is open. That's why this becomes 1. X1 already closed. That's why this is also 1. This way, this path is used to turn on the lamp. So, second person also reached the first floor. Now, he changed the state of X1. That is state 1. That is state 1. Both will be open. The lamp will not glow. This is the first experiment. Do you understand this? This you can simulate as well as you can run on a PLC. First you have to simulate, then you have to run on the PLC. PLC will be given. In that PLC, you have to upload your program and you have to check whether it is working or not. Do you understand that? So now let us check whether it is working in simulation or not. Enter the program title and program name, file name. Both I am giving the same. Your hardware type is SA2. You can select many, but our hardware type is SA2. That's why we are selecting SA2. Module type PLC. That's all. You will get a blank page. There you have to write the program. Pick and place. So here, normally open contact is available. That is called normally open contact is required. First contact what? We put X0. Normally open contact. So let us put normally open contact. Or you get here, it is X. Name is X. Device number 0. If you use first switch, start with 0, second switch 1, 2, 3 like that. So comment, this is start button. If you want, you can give, otherwise no need. No, it is not start switch, staircase switch, no need. Okay. Yes. I got X0. In series with that, normally closed contact, that is the next contact. Normally closed contact. Its name should not be X0. It should be X1. That's all. So here I need a coil, output coil. Its name is Y0. Yes, I got output coil. That's all. First part is over. Second part, second rung. The first line is called a rung. RUN. First rung is over. Second rung we have to draw. Second rung X0 bar. Normally closed contact with the same name. So normally closed contact. Already I told you that X0 means is in my image table. It is a memory. You can use any number of times. You can invert and you can use. So if you put a normally closed contact, it means you are using X0 bar. So X0 bar you need. So give X0 bar, normally closed contact. Then X1, you have to use normally open. X1, you have to use normally open. Now you have to connect these two. For that, this is what? Vertical line. This is a horizontal line like that. So we put both in parallel. So XOR gate is over. Now we have to compile and test by simulation first. First we have to simulation by test. First we have to save that program. Already we gave the name. It is test2. It is saved. Now we have to compile that. Compiling completed. You can note down in the left bottom. Compiled. If no error means it will be compiled. Now we have to run by simulation. If you want to upload, you have to get into communication and that we will see later. We are not going to run in a PLC. If you want to run in a PLC, you have to upload this program into PLC. The compiled program will be uploaded into PLC. There is no need of this laptop or PC. Once it is uploaded, you can disconnect. But if you connect, the status will be reflected here. The software is written such a way that you can see the status. Whether whatever the values available, that will reflect in that variable. It is written like that. The softwares are interfacing. But once you disconnect also, it will work. because the program is embedded into that embedded system. So now if automatically this end line will be included, or if you enter end, if you type end, it will be coming. Otherwise, if you put end, compile automatically, the end line will be included. Automatically, end line will be included. Now we have to simulate. For that, here simulator. We need a simulator. Then we need a online mode to check. We need a online mode. What status of X1? Normally open, you know. That's why it gives 0. That's why it becomes 1. 1 means green. 0 means white. So now you have to run. It is in stop mode. The program is stopped. Even then, what PLC will do? Read the input image table, run the program. No program is there. Update the output image table. That automatically it will be done inside, whether you wrote program or not. That is the function of PLC. But if you upload this program, based on this program, it will do. Now you have to run that. If you run, yes, now it is in run mode. Now you can give input. There is no hardware to give input. That's why I will simulate. I am changing the value in the input image table. Here, there is no push button. I can toggle the values. I cannot use, for this program, toggle switch only required. For this program, what is required? Toggle switch. In some program, push button is required, but you cannot simulate push button. That's why what you have to do? Turn on, turn off. Push button means if you press on, release means off. If you use a toggle switch in place of push button, what you will do? On and off. Then it will be like push button. I mean, understand that? But it is toggle switch. That's why we are going to use it as a toggle switch. I am in the ground floor. It is in open. Both are open. I am set to on. Means I am turning on the switch. Lamp is turned on. Why not is 1 become? Why not becomes 1, you know? The lamp is turned on. What happens to X0 bar? 0. Now I am in the first floor. What switch is available for me? X0 or X1? X1 is available. So what I will do, you know, X1 is available, not X1 bar. X1 is available on the first floor. What I will do is, I will set this on. Lamp is turned off. Lamp is turned off. Another person is coming. Where he will come? X0 only available to him. It is in ground floor. So set off. Again, lamp is turned on. He will come to first floor. What is available to him? Not X0. X1 is available. Set off. Turned off. So it is working. You understand this? Okay. So now what you have to do, you know, you have to upload this. They will tell how to upload and all. You have to upload this. Just you have to click. It will upload into the PLC program, PLC module, and you can. There will be 2 toggle switches there. By operating that, I think it is connected to X3 and X4. Am I correct? So you have to write a program like this, X3, X4, not X0, X1. I understand this? Because the hardware is connected at X3 and X4. X0, X1, X2 is connected with push button. So it is module available in the lab. X0, X1, X3 has push buttons. X3, X4 is connected to toggle switches. For staircase, you need a toggle switch. That's why you have to write program for X3 and X4. Fourth part of first experiment. Turn on a lamp after 5 seconds. Turn on a lamp after 5 seconds. Delay when the start push button is pressed, and turn off immediately when the stop push button is pressed. So we need a same arrangement. That's why put a open contact X0. X0 is we are using it as normally open switch, normally open push button. X0, X1 also normally open. So we are going to use X1 and X0 and X1 to turn on and off. So we will put X1 also to turn off. So that's why we are putting normally closed, because that is normally open. Push button is we are using. When you press, it will close. That's why to turn off X1 is used here. So M0 will be used instead of Y0. We are putting M0. Why M0? Because we should not turn on the lamp immediately. That's why we are using a memory variable M0. So we need a ceiling contact to keep the lamp on. That's why M0 can be used here. M0 can be used here. Here also that same problem will come. Now we will use M0. Later we'll replace by Y0. M0 will use as ceiling contact. So this is if you use M0, and in M0 if you connect Y0, lamp will immediately turn on and immediately turn off. But we don't want to turn on immediately. That's why we have to use M0 to turn on a timer. That's why put M0. Put M0 as timer. So put M0. With a timer. We are going to use a timer with the tag 0, and the timing we are going to use some say 25. We gave this timer will be used to turn on the lamp. So timer T0 will be used to turn on the lamp. The lamp is connected at Y0. So if you press X0, M0 will be 1. So M0 will turn on the timer. The timer will turn on the lamp after 5 seconds. It works fine. If you press X1, immediately M0 becomes 0. As M0 becomes 0, timer output also becomes 0. That's why immediately it will be turned off. It works fine, but the ceiling contact we have to check. Ceiling contact, because of X1 is in series, ceiling contact also will go off. No problem. That problem will not come here. Yes. Now let us save this. Compile. Compiled. Now we have to simulate. We have to keep online mode. And then we have to run this. Yes, we keep this in run mode. Both the X1 and the X0 both are normally open push button, as we assumed earlier in the previous program. Same two inputs we are using. So X1 is open, that's why it remains X1 bar is 1. It is in green. Now let us turn on the lamp. Set on. So still the lamp. Oh, we put Y0. We should put T0, you know. Timer will turn on the lamp, no. All are keeping mum. I think you didn't understand. T0. Okay. Save. Compile. And simulate in online mode. Hit on. Off. After 25 count, it is turned on. If you turn off, it will be turned off immediately. Set on, it is immediately turned off. If you set off, so set on, it is turning on after 25 counts. Yes, it's working fine. Set off. Immediately it is turned off. It's working fine. Now the next program is whatever the earlier device, the same device you need to run the show. But if it is a PLC, if the hardware is modified, according to that program can also be modified. If you write a PLC program to operate 1 HP motor by pressing start and stop push buttons, incorporate a push button for jogging operation of motor. First program what we wrote, to turn on a lamp. Before staircase we wrote the same program we have to write to turn on a motor. Instead of lamp, we have to turn on a motor. That's all. So we need a start button, start push button. That is required. That is X0. Start. Then to stop, we need another, normally open or normally closed. What I have to use? Normally open or normally closed? To stop. How you are saying closed? Depends upon the hardware. Depends upon the, I'll tell. Depends upon the hardware. Suppose the hardware is always give one, means here what we have to put normally open. Because it always gives one. We wrote the program like that earlier. Always it gives one. That's why we put normally open. Suppose we put normally open, another push button you are putting. That is normally open, means here what we have to put normally closed. We have to put normally closed. You understand that? We will write like that. We'll put normally closed. If you put normally closed here, that name is X1. I am putting normally closed here. It means what? Both switch will be open initially. Both switch will be open initially. If you press X0, motor will be started. If you press X1, motor will be stopped. Have you understand that? Have you understand that? Okay. So both are giving 0. First one will be 0 only, and this will give 1 because both switches are open. That's why this gives 1, this gives 0. 0 and 1 equal to what? 0. That's why it will not turn on. Have you understand that? Why not? That's all. What happens to X0? Name, I gave the same name. That's the problem. Yes. Now we need a ceiling contact. So here in the second rung, we have put a normally open, but what should be the name? Why not? Because why not is the output. You have put here and put that's all. Now, if you press X0, motor will be turned on. If you press X1, motor will be turned off. You understand this? That's all. But we need a jogging operation also. So instead of why not, I can use memory variable. That is also possible. Because the PLC will be sold like that. 8 output, 16 output, 32 output, 64 output, like that it will be available. If you use more and more output modules, you cannot write more programs because you are using the output modules. Instead, you can use memory for some variables. For important outputs only, you are using the output module. Have you understand that? So instead of using Y naught, I can use M naught. M naught is only for memory. It is not available in the output module. Have you understand that? It is available only in the output image table, not in the output module. It is available in the output image table, not in the output module. So I can change the name like instead of Y0, I can change M0. I can change M0. So I changed M0. It is not available in the output, but it is memory variable. That can be used because I have to do jog operation also. So here I am putting third rung is I am putting one more contact here, and its name is M0. Its name is M0. Here also ceiling contact also what? It should be M0. Double click and change the name to M0 because we changed the output name. So it also must be M0. So M0 is available. If you connect the device Y0 in the output, if you connect Y0, Y0 is connected in the output. Yes. Now motor will be connected at Y0, not M0. M0 is only memory variable. That memory will be placed here. That memory will turn on the motor. Now I need a jog operation, or the motor should run for jog operation or switching operation. So I am putting or. That's why I am putting in parallel. So one more jog operation, that is X1. Another input, that is X1. It is for jogging. Jogging. That's all. When once I press the X0, motor will continuously run. Motor will continuously run. Programming is over. Now let us compile this program. Compile this program. Is compiled. It is saved. First we have to save, then compile. Compiled. Now let us simulate. For now simulator is turned on. Online mode is required. If you put this online mode, if you run the program connected with PLC, whatever the data available here, it will reflect. Suppose the motor is on, means this Y0 will be 1. Green. For that online is required. It will interface automatically. Okay. So now it is in stop mode. The program is in stop mode. I want to run that program. So here I have to run. It is in run mode. I want to turn on the motor. Motor is connected where? Y0. Motor is connected to Y0. M0 is memory variable. M0 is memory variable. So I have to turn on that X0. It is push button, but I am having toggle switch. That's why I have to turn on and off. Set on, set off. But motor is still on. That's all. The motor remains off. I want to jog. Jog means which I have to use. So it should be X2, you know. Should be X2. I use the same name. All are sleeping. Okay. It should be X2. Yes. Save. Compiled. Then simulator. Then online mode. Then run mode. This is in run. So we are turning on the motor by setting X0 on, then immediately off, but motor is running. Suppose you want to turn off the motor, you press X1 once, set on and off. Motor is turned off. If you want to jog, you have to use X2. . Set on jogging. for some time, then I turned off. X2 is used for jogging. X1 is to stop. X0 is to start. You understand this? That's all. In the connection diagram, this is input module. You have to draw in the examination. So 5 volt will be available. Plus 5 volt is available. That you can take. The switches are available. This is X0. This is connected to X0. Another switch is available. That is also normally open. This is normally open. This is also normally open. This is connected to X1. This is connected to 5 volt. This is also connected to 5 volt. This is the connection diagram. X0, X1. Then X2 is there for jogging purpose. X2 is there. That is also another push button, normally open. That is connected to X2. This is also connected to 5 volt. This is also connected to 5 volt. That's all. This is the connection diagram in the input module. But already it is available in the lab. That's why no need to do. Then in the output module, what you have to do? In the output module, no M0 is available. Y0, Y1, Y2, Y3 is available. Neutral is available. Neutral is available. 230 volt is available. It is a 230 volt output module. They will sell like this. 12 volt output module. They will sell like that. 5 volt output module like that they will sell. 230 volt output module like that they will tell. 440 volt output module. Current also they will mention. I am not mentioning here. They will tell like that, the output module. Here, let us assume that it is a 230 volt output module. In that Y0, I am connecting the motor. I am connecting the motor in the Y0. That's all. It's working fine. This is PLC. This is PLC. The output you can see only input module and output module. And the communication cable will be there. Communication cable, power supply will be there. Communication cable to PC is power supply to power supply. Power supply cable. That's all. And here indicators will be there. Y0 is on means this will the LED will glow. If it is on means similarly if X0 is on means here LED will be there. X1 on LED will be there. Here on LED will be there. It will glow. If it is 1 means, logic 1 means. Logic 0 means it won't glow. From that, which one is on and off, you can understand. Sometimes in industries, alarms are required. For example, a pressure vessel is there. If the pressure exceeds its strength of the vessel means it may blast. To avoid that, the pressure exceeds, the operator needs an alarm. That is called alarm. For that alarm, we have to manage that. How to manage that alarm, that we will see today. Suppose a red lamp, generally a red lamp will be there. The red lamp will glow if the pressure exceeds the safer value, exceeds the safer value. So there will be a sensor that will sense whether the pressure exceeds the safer value or not. So that sensor senses that pressure value. Based on that, it will turn on a relay. This is conventional method. This is the conventional method. This is the relay and contactor is there. In that, a lamp is connected. Alarm lamp is connected. Another end is connected to neutral. This end is connected to phase. The signal, say 1 means plus 5 volt is available and this is grounded. The pressure signal exceeds, the sensor will give plus 5 volt. That's why this relay will be energized and it will close this contact so that this lamp will glow. Whenever the pressure falls below the safer value, then this lamp will be turned on. This is conventional. The same can be done by using PLC. For that, what is available? A plus 5 volt is available from the sensor. Logic 1 is available whenever the pressure exceeds safer value. So that signal is to be used to operate the PLC. So the PLC in the input module, X0 will receive a signal logic 1 when the pressure exceeds the safer value. Logic 1, if pressure exceeds safer value. This logic 1 can be used to operate the lamp. This is PLC. In the output module, at Y0, a lamp is connected. A lamp is connected. This is neutral. This is Y0. That is Y0. This is Y0. Logic based on that, this is 230 volt. Let us say single phase. This is the connection diagram. The programming is whenever the pressure exceeds safer value, the lamp has to blink, because if the lamp is continuously glow, no one will get that attention. To get attention, the lamp has to blink. For that, we have to generate a square wave. For that, every second it will blink. Every second or every 5 seconds it will blink like that. We have to write the program. For blinking, we have to generate the square wave. For that, we'll use a timer. Timer T0 for 1 second. Timer T0 for 1 second. That is used. The input signal is from the second timer. The second timer, this is turned on by T0. Another timer, that is, this is also timer T1. This timer is T1. This is also for 1 second. This is normally closed. Normally closed, this is normally open. Let us assume that initially both are off. Yes, both are off. It means T1, here the T1 is connected. The output of this timer is connected here. T1 is logic 1 because normally closed. Because both the timers are off. Initially both timers are off, therefore T1 is 1. Therefore this timer started. This is on delay timer. On delay timer means it will on after 1 second. It will on after 1 second. So after 1 second, this will turn on. Which one? This T0 will turn on. That means this becomes logic 1. This becomes logic 1. Therefore, it will start this. When this will turn on? After 1 second. After 1 second, this becomes 0. After 1 second, this becomes 0. That's why till then, this timer turned on. Till 1 second, it will be on. After 1 second, because the T1 becomes 1 means T1 bar becomes 0. That's why it will be turned off. Immediately, it will be turned off. Turned off, but this turned off means T0 also becomes 0. That's why T1 immediately turned off. Immediately T1 also turned off. So again it becomes 1. Again it becomes 1. The fraction of second, momentarily it becomes 1. Which one? T1. This is, this is T1. This is T0. T0 is 1 second it was on. Momentarily it becomes 1. That time T0 becomes 0. Again, the signal becomes 1. That's why after 1 second, this will again on. After 1 second, because on delay timer. Now this becomes 1. After 1 second, this becomes 1. Again, T1 will become 1 after 1 second. After 1 second. Till then, this T0 will be 1. Therefore, T0 will be a square wave of 1 second duration. T0 will be a square wave of 1 second duration. This T1 will be like this. A pulse will come every 2 seconds. Every 2 seconds, T1 will generate a pulse. That's all. Turn on, immediately it turns off. Turn on, immediately it turns off. Therefore, this T0 can be used to blink the lamp. So the T0 can be used to turn on the lamp. Another signal is required. If pressure exceeds, the lamp has to glow. When the pressure exceeds, X0 will be 1. Therefore, X0 we have put here. If X0 is 1, the lamp has to be turned on. And it should blink. That's why you put T0 also in series with that. T0 also in series with that. Then that Y0 is, the lamp is connected at Y0. So what will happen? Whenever X0 comes, whenever X0, that is pressure exceeds the safer value, X0 will be 1. X0 will be 1. X0 equal to 1. T0 is a pulse signal. Every 1 second, 1 second square wave. That's why the lamp will glow 1 second, then turn off 1 second. Turn on 1 second, turn off 1 second. Like that, it will blink so that the operator will get attention that some variable is exceeds its limit. But there must be a difference between operator notice the deviation. Immediately he cannot do anything. He has to do something to bring the values within safe limit. For that, he has to do something. But there is a difference between whether the operator notice the change or not. For that, some difference is there. For that, there will be a signal called acknowledge signal will be there. So here, one more button is there. That button is called acknowledge, AC, acknowledge. That is X1. So here, another signal is available. Another push button is available. That push button is called acknowledge. That is connected to X1. Here, plus 5 volt is given here. So if you press that, that 1 will come. It means operator acknowledged. So that X1 is coming here. That X1 is used to acknowledge. That is M0, memory variable M0. So here, if you put a ceiling contact, if you put a ceiling contact M0, this will be continuously 1. It means it is acknowledged. When we have to acknowledge, if the signal comes, then only. If the pressure exceeds, then only we have to acknowledge. That's why that also in series. That X0 also in series. If signal comes, he will acknowledge. Therefore, M0 becomes 1. If the operator, I know the pressure exceeds like that. He pressed that acknowledge button. So the blinking must be stopped, but it should glow. Why? Pressure is still exceeded. That's why if you put that M0 across T0, if you put the M0 across T0, what will happen? T0 is blinking. M0 is not blinking. So it continuously glow. If the lamp continuously glowing means the operator acknowledged that the pressure exceeds its limit. If it is continuously blinking means operator not yet acknowledged. Suppose the pressure came within that limit, X0 will be 0. X0 0 means what will happen? You see, X0 0 means Y0 becomes 0 because X0 is in series. Y0 becomes 0. Here also X0 is in series. Acknowledge also gone. Acknowledge also gone. And blinking also, lamp also turned off. Lamp also turned off. That's all. This is called alarm management. That we will check by using simulation. Normally open T naught. Again timer. This is T1. It is 0.1 seconds. That's why we are giving 10. Okay. Square wave is generated in T naught. Now, if pressure exceeds the safer value, X naught will be 1. Therefore, we have to use X naught here. X naught is used. And T naught also used. We are going to use T naught for blinking. First, let us put T naught. T naught, then X naught. Then X naught. X naught is signal. Now we have to connect the lamp at Y naught. That's all. Now we have to acknowledge, that is M naught. Sealing contact is required, that is M naught. Across T naught. Then we have to acknowledge. For that, we are going to use X1 for acknowledgement. X1. X1 is used to acknowledge. That is M naught. M naught. M naught is generated, but it is a push button. X1 is a push button. That's why we need a sealing contact to keep that value. So we have to put a sealing contact for M naught. That's all. Now we have to save that. Compile it. Run mode. No signal. But T naught is blinking. T naught is blinking. Always it blink. But X naught is not coming. That's why Y naught is not yet turned on. The lamp not yet turned on, because lamp is alarm lamp is connected at Y naught. So for that, X naught is required. So we have to set the X naught. If you set the X naught, Y naught is blinking. The lamp is blinking. If you acknowledge, it continuously glow. For that, we have to set that X1. I pressed and I have to remove that because it is a push button. If now Y naught is continuously glowing. But the operator does something, the pressure, or automatically the pressure falls below the safer value. That's why the signal goes off. Y naught also goes off. But M naught is in on. What is the bug? Bug is we have to put the X naught in series with M naught. That is the bug that will do. So we have to turn off this. Here we have to put one X naught. Otherwise, M naught is continuously on. Next alarm signal, it will come as acknowledged. To avoid that, we have to put X naught in series with that. Yes, we included. Now save, compile. Simulate online. Run. T0 is blinking. Now let us set X0. Y0 is blinking. Let us acknowledge by setting X1 and set. It is a push button, that's why immediately we are setting off. So it is continuously glowing. Now let us assume that the process variable came within that limit. That's why we have to put set off. Only T0 is blinking. Only T0 is blinking. It's working fine. If X0 comes, again it will blink. The lamp is blinking. Acknowledge. Blinking is stopped. It is push button, that's why we are immediately set off. Let us assume that X0 came within that. X0 is not coming because the process variable came within that limit. Set off, it is turned off. It's working fine. This is the second program, second experiment. Programming a PLC for batch process. This is the batch process. This is the batch process. Batch process means, you know the difference, already you studied process control, that's why you know the difference between batch process and continuous process. Continuous process will run forever, at least for 3 months or 6 months. After that, deliberately they will stop to check whether the instrumentations are correct or not. For service only, routine service only, they will off. Otherwise, it will continuously run. If any instrumentation fails, it leads to accident. That's why they will turn off after 3 months or 6 months. That is called a continuous process. Batch process means it will be used to manufacture syrup, tonic. So whatever the batch number will be there and the packing this is for legal purpose. So they will keep one set with them and one will be with the government. If any problem is there, that will be goes under legal proceedings. That's why there will be batch number that shows at which batch it is manufactured. If you know that number on which date it is manufactured, they can find from their ledger. So this is one such batch process. Here it is a tank. Yeah, tank is there. The tank will be filled up to this point. Then the heater will be turned on. The heater will be turned on. For that, there is a temperature sensor and the set point is there. Once that set point is reached, the sensor output will be 1. The temperature reached means the output of that sensor will be 1. The temperature is not yet reached, that set point means it will give 0. So once the temperature is reached, the temperature transmitter will give 1. That will be used to turn off the motor, heater. Heater will be turned off. Always you need a stirrer because otherwise the temperature will not be uniform in the entire tank. That's why a stirrer is there. That stirrer, whenever you turn on the heater, the stirrer has to be turned on. Stirrer will be connected at Y3. Stirrer will be connected at Y3. So once the temperature is reached, then we have to wait for some time. Say 50 seconds or 100 seconds, we have to wait. A delay timer will be there. During that time, we have to wait. After that, we have to drain. So actually what is happening? We cooked something in the container. We are filling the tank, heat it, stir it and heating it till the required temperature reaches. Once it is reached, we will keep in that temperature for some time. Then we are draining the tank. That's all. That is called one batch process. One batch process. You understand this? Now we have to turn on the inlet valve, means tank will fill the liquid. It may be syrup or something. Some liquid will come. For that, we have to open the valve. Y1 has to be, it will fill by gravity. Gravity will be used to fill the tank. So just to open this valve Y1, it will fill the tank. Before opening, what and all has to be checked? What and all has to be checked? What and all has to be checked to fill the tank? Before that, let us remember what are the variables used. And here itself I will draw that. So this is the input image, input module. This is the input module, PLC. This is output module. This is output module. What and all input? This is the tank must be empty. Tank must be empty first. Then only you can fill. Already it is filled means why you have to open the inlet valve. Therefore, to indicate whether the tank is empty or not, one proximity switch. This is called what? Proximity switch will be there. That proximity switch will give one if the tank is empty. That proximity switch will be fitted in the bottom of the tank. That will give 1, the tank is empty. That will give 0, the tank is not empty. The tank is not empty means, not empty means it will give 0. Empty means it will give 1. Therefore, one of the input is X2. Another input is there. If the tank is full, this proximity switch will give 1. If the tank is full, X3 will be 1. X3 will be 1. Another proximity switch. So instead of push button, we are using some sensor, proximity switch to sense the process variable. Here, if the tank is full, that proximity switch will give X3 equal to 1. The tank is not full, it will give 0. The tank is not full, it will give 0. 2 inputs. One more input we are going to use to turn on this batch process. We are going to use a push button that is connected to X0. That is connected to X0. One push button is we are going to use. That is push button. That we are going to use. That is X0. We are going to use turn on the batch process. Another push button to turn off the batch process. We are going to use X1. So X0 push button is normally open. This is normally open push button. Normally open push button. This is also normally open push button to turn on and off. X2 is to check whether the tank is empty or not. X3 input is to check whether the tank is full or not. Next, it is not sufficient. If the tank is empty, we can open inlet valve. Where inlet valve is connected? At Y1. Inlet valve is connected at Y1. We can open inlet valve if the tank is empty. It is not sufficient. The outlet valve must be closed. The outlet valve, otherwise, if you open, it will drain away. It will drain away. That's why we have to check whether the outlet valve is closed or not. Outlet valve is closed or not. That we have to check. Yes. We have to check outlet valve also. Then Y2 is used to turn on the heater. Y2 is to turn on the heater. Y3 is to turn on the stirrer. Y1 is turn on inlet valve. Y4 is to turn on outlet valve. If this is Y4 equal to 1 means the outlet valve will open and drain the tank. Start draining the tank. Why not? Why not is nowhere mentioned. Okay. Based on the diagram, they wrote the program. That's why not is not used. Okay. So now we have to do the hardware wiring. A push button is required to turn on. This is plus 5 volt, plus 5 volt. It is connected to X0. This is to start. Another one is there. Another one is there. That is connected to X1. That push button is to stop. Proximity switch. X1 is there. X2 is there. X2 is there. That shows empty 1 or 0 to show whether the tank is empty or not. X3 also connected. That gives 0 or 1, depends upon if the tank is full, it will give 1. If the tank is not full, not empty. Not full means it will give 0. So that will give, these are the inputs. Outputs, Y1 is inlet valve. Y2 is for heater. Y2 is to turn on the heater. Y3 is to turn on the stirrer. Y4 is to turn on the outlet valve. Any other output? No. That's all. X4 is there. One more input is there. If the temperature is reached, this temperature transmitter will give 1. If the temperature is reached, that is connected to X4. So how many inputs? X0, X1, X2, X3, X4. 5 inputs. How many outputs? 4 outputs. Y1, Y2, Y3, Y4. That's all. Now we have to write the program. Here itself we can write. X0. Push button X0 is to turn on. X1 is to turn off. Let us put M0. Memory variable M0. We'll use M0 everywhere. To stop all runs, it is better to use one variable to turn off all runs so that we can use in every rung M0. So M0. Sealing contact is required. That is marked here. So M0 as third rung is M0. Now we have to open this valve. Before that, what and all has to be checked? Whether the tank is empty or not. For that, X2 will give 1. X2 will give 1. Therefore, you put the M0Y, the program is running. Then next thing is X2, if you put the tank is empty. M0 is 1, X2 is 1, then we can open the inlet valve. It is not sufficient. Whether the outlet valve is closed or not, otherwise it will drain, That's why we have to include that outlet. Outlet, you see, if the valve is open, it is 1. Y4. Y4 is used for that. If it is 1, it is open. If it is 0, means it is closed. It must be closed. That's why a 0, Y4 must be 0. That must be 1 here. That's why we are putting normally closed contact Y4. So if Y4 is there, then we can use. That's all. Now we can turn on inlet valve, but it is not sufficient. Because if you open some valve, there must be a provision to close. Otherwise, tank will overflow, When we have to close, the tank is full, we have to close. So if it is empty, if it is not full, not empty, here not full. 0 means not full, not empty. Not full. So if it is not full means it is 0. 0 means we have to include that also, X3 also. X3. Then what is the inlet valve? Y1. Is it sufficient? What and all we are checking? M0. That means program is turned on. X2. It means tank is empty. Y0 bar. It means outlet valve is closed. Next one is X3. Tank is not yet full. Tank is not yet full. These are all required to turn on Y1. We turned on Y1. Now tank is start filling. Is it sufficient? Whether it is completed? Whether it is completed? No. Because if it starts filling, what will happen? This level will raise. Am I correct or not? This level will raise. If it goes above this proximity switch, it will give you a 0. Because tank is not empty. Tank is not empty. That's why it will give not full, not empty. Here we have to write not empty. Not empty. Not empty means it gives 0. Empty means it gives 1. Full means it gives 1. Not full means it gives 0. That way we have to write. The diagram is not correct. So not empty. If the level starts filling means it is not empty. That's why it will give 1. Empty means it will give 1. If it is not empty means it gives 0. That's why the logic will be changed. Once the level reached the first proximity switch, the logic here will be changed. The logic here will be changed. That's why inlet valve will be closed. You cannot open till it fills. That's why across X2, we have to connect Y1. Across X2, we have to connect the sealing contact Y1. Y1 is connected across X2 because after some time it becomes 0. That time the Y1 will conduct. That time the Y1 will conduct. I understand this point. So these are all we have to think and write. No other go. So now the program will fill till the tank comes up to full. So once the tank becomes full, what is the value of X3? X3 becomes 1. X3 till now X3 is 0. When the tank becomes full, you notice that when the tank is full, what is the signal it gives? 1. 1 means this becomes 0. That's why inlet valve will be closed. Inlet valve will be automatically closed. It is working automatically. Inlet valve automatically works. The tank is empty. Outlet valve is closed. It is not full. It is not full. And if the level raises, then we need a sealing contact. That also we have put Y1. So that's why it works fine. Y1 is working fine. The tank is empty. Automatically the valve will open and it will fill till the tank reaches full. Till the tank reaches full. That's all. Now what we have to do? What is the sequence of operation? Next sequence is we have to turn on the stirrer and heater. Both should be turned on. When we have to turn on the heater and the stirrer, that we have to write. When we have to turn on the stirrer and heater, when we have to turn on the heater, the tank is full. The program is turned on, M0. The tank is full. Tank full means X3 equal to 1. We can put the X3. Tank is full, then only we have to turn on the heater and the stirrer. Any other thing? Any other thing? X4. X4 will give 1 if the temperature is reached. Now it is not yet reached. Now it is in room temperature. That's why what is the value of X4? It is 0. So it should give 1 to turn on the heater. That's why we have to put the X4 not. Because now X4 is 0. We have to convert this into 1. Now it will give 1. M0 is 1. X3 is 1. X4 bar also 1. Can I turn on the heater? Yes, we can turn on the heater. But there is, if the temperature is reached, automatically it will be turned off. Automatically it will be turned off. So here heater is at Y2. One more output is there. That is Y3. That is stirrer. Both will be turned on if the tank is full. In 2 ways we can operate the heater. One is we can keep the temperature at required level, then turn off and keep for 100 seconds or 200 seconds, then we can drain. That is one way of programming. Another one is you want to keep the temperature at the set point means we have to again, if the temperature falls below that set point, the heater again turned on means we have to include that also in that run. I understand this point. Suppose temperature we want to keep 100 degrees centigrade. Now 100 degrees is reached. Now we are keeping this X4 becomes 1. That's why heater is turned off. We are keeping for 5 minutes, we are keeping the tank as such in the temperature. But temperature falls below 100 degree means it is not good, means we should turn on again the heater. In that case, we have to include for that also. Have you understand that? Otherwise, it is okay. Otherwise, it is okay. To reach temperature of set point, X4 will give 1. Till then, the heater and the stirrer will be working fine. So, how long it has to wait? It has to wait in that program, in the requirement it is written. It has to wait 5 minutes. It has to wait 5 minutes. We cannot simulate for 5 minutes. We cannot wait 5 minutes to simulate. Let us put some 25 numbers. That's all. But 5 minutes it has to, we have to keep it and the temperature. So we need a timer. We need a timer. How to turn on the timer? When we have to turn on the timer? To turn on the timer, M0 must be 1. M0 must be 1. Tank must be full. Tank must be full. Am I correct or not? Tank must be full, X3. Then X4, yes, let us use X4 also. X4, it reaches set point. So X4. Then if you put X4, suppose timer is 5 minutes, means the temperature falls, what will happen to X4? It becomes 0, you know. That value will change. That's why if you put X4, that problem will come. Have you understand that point? So we have to think, okay, anyhow, X4 we are putting. Then we can use Y2. If Y2 is tank is full, once the heater is turned off, then only we have to turn on the timer. For waiting period. For waiting period, when we have to turn on the timer? After heating. When heating is over means we can use the heater instead of X4. Instead of X4, we can use the heater. So in place of X4, we can use Y2. Y2, not Y2, Y2 bar. Once it is turned off, it will be turned on. So tank is full, heater is off, M0 is 1, so timer will be turned on. Timer will be turned on. But at the same time, any other thing has to be included. X4 is included, but in the record note, X4 is there. But if you think practically, it will not work out. But here in simulation, it will work. We will keep X4 1. Simulation, it will work. But in practice, before 5 minutes, the temperature will fall, means that the value will change, you know. In practice, it will not work out. Anyhow, if you want, you can include that also. X4. Then we have to put the timer. So let us assume that temperature at set point. So now we can put the timer. 5 minutes. 5 minutes delay timer. After that, what we have to use? After 5 minutes, we have to open the valve, outlet valve. We have to open the outlet valve. So to open that outlet valve, what and all required? M0 must be there. Program must be run mode. That's why M0 is required. Then what is required? T0 must be on. That T0 must be 1. T0 must be 1. Then heater must be turned off. Heater must be turned off. Heater Y2. Heater should not be on. Any other thing? That's all. The output is Y. Outlet valve is Y4. Outlet valve will be open. Will it work? Tank level must be 1. Tank level must be 1. That is not included. Let us include that also. Tank level X3 must be 1. And M0 is there. M0 is there. So will it work out? The tank is full. Heater is turned off. Y2 is what? Y2 is heater is turned off. T0 is timer is on. Timer will be on. So X3 is 1 means will it work? Now the valve is opened. That's why level will fall. After some time, X3 becomes 0. The level falls below this proximity switch. The level becomes 0. It is not full. That's why it will not work out. That's why we would put a ceiling contact across this. We would put a ceiling, but here it will work. While heater is turned on, we are not draining. There it will work, but here it will not work. If this becomes 0, X3 becomes 0, timer output also becomes 0. That's why we would put across these two. This Y4 should be across these two. Across these two. That's all. Across these two. Then it will completely drain. But is it sufficient? When the valve has to close, when it becomes empty. That's why it is not empty has to be included. Empty means what? 1. X3, X2 is 1 when it is empty. Not empty means it is 0. That's why we have to include X2 here. We have to include X2 here. So we have to include X2 not here. So once completely drained, automatically valve will be closed. Automatically valve will be closed. Anyhow, we are checking there. While opening inlet valve, we are checking there. If we didn't include, it will not close. It will not close. That's why it will not open the inlet valve. If we didn't include the X2 here, so always if you write some logic for opening means, you must include some logic for closing also. This way you have to remember. While writing program, if you include something for opening means, you should include something for closing also. So here for closing, we included X2. For opening, what and all we included? M0, X3, T0, Y2 bar. 4 inputs are in series to open the valve. To close the valve, X2 is sufficient. The tank is empty, it can be closed. The tank is empty, it can be closed. Once it becomes 1, it becomes 0, so outlet valve will be closed. Why we put the ceiling contact across T0 and X3? Because once it starts draining, X3 will not remain 1. That's why timer will be turned off. So across timer and X3, we put the ceiling contact. We put the ceiling contact. That's all about that program. So you are going to simulate this. The first one is M0. Already hardware wiring already we have seen. Hardware wiring is here. So we are using normally open start button, normally open stop button. And we should remember the proximity switch status. If it is empty 1, if it is full 1, otherwise 0. Empty 1, full 1, otherwise 0. We have to remember all this while writing the program. Okay. Now we have to include X0 to turn on, X1 bar to turn off this program, and we have to include M0 memory variable to keep the program running or off. You need a ceiling contact. You need a ceiling contact. That must be M0. That's all. So M0 will be 1 if you push the start button. If you press X1, it will be stopped. At any point of time, you can stop. So now, one more thing I want to mention, but you will not have such a situation. If you stop in the middle, you cannot run again. Sometimes the signal, the program will not allow to run, because we are writing the program for sequence of operations. The sequence is correct, then only the program, that batch process will work. If some other situation comes, it will not work. None of the run will run. I understand this. That's why if you stop in the middle, it may not work. So while simulating, you have to give correct signal sequence here. While if you want, really, if you want to write a program for real time, then you have to think many things. But we are not doing that level. So suppose if we stop it in the middle, no logic is satisfied means it will be as such. Suppose the tank is 50%. You stopped in the middle. You cannot drain because when you can turn on the outlet valve, the tank is full. But you stopped in the middle. The tank is not full. How you can open the valve? You cannot open the valve. So those provisions we have to provide in the program. Now you understand this, but we are not doing like that. It is not a complete program. We are just simulating to understand the PLC. That's all. You understand this problem? Okay. Then we have to put M naught. M naught. M naught X2, Y4, X3 bar. We will put X naught, X2 first so that it looks nice. Otherwise, you have to put 2 vertical lines. To avoid that, let us put X2 first. X2 first. Then M naught. X2 first. X2 first. Then M naught. Then M naught. We have to open the valve. What and all we checked whether the outlet valve is closed or not. Why not bar? Why not bar? Why not bar? Y4 bar, sorry. Y4. Y4 bar. Then Y4 bar. Then X3 bar. Why? The tank is to close the outlet valve, it must be X3 bar. X3 bar. So we have to include X3 bar also. X3 bar. It is not full. Then X3 bar is because if it is full, it will be 1. It should be 0 to fill the tank. Outlet valve is Y. What is that? Diagram is Y. Inlet valve is Y1. Y1. Inlet valve is Y1. So we are checking whether the X2 means what? Whether the tank is empty or not. M naught is whether the memory variable is 1 or not. Y4 is whether the outlet valve is closed, whether the tank is not full. But this X2 is, this will not work out after some time because if you start filling, the proximity switch first it will be merged inside the liquid. That's why it will not give 1 after some time. It's not empty. That's why we have to put a sealing contact here across X2. Across X2. We have to put a sealing contact. Across X2, we have to put a sealing contact to Y1. We have to put to Y1. To keep this on. To keep this on, we need this. That's all. Now, the inlet valve will open and fill the tank. That part is over. Now we have to turn on the heater. If it is full, the inlet valve will be closed automatically. By using a X3, automatically it will be closed. Now we have to turn on the heater. To turn on the heater, what and all required? M naught is required. And the tank must be full. Tank must be full. Then what and all we included? M naught is required. X3 tank is full. X4, what is X4? It is not reached the set point. These 3 we have to include. So now let us write that you need M naught. M naught is required. M0 is required. The tank must be full. For that, the signal is X3. X3 must be 1. X3 must be 1. Then third point is when it has to stop, when it reaches X4, when X4 is not 1, the heater should be on. Therefore, when it is not 1, that's why we have to include one more not. It is not 1, which is X4. X4 is not 1. Yes. Then the timer should be started. The timer should be started. The timer. Heater, sorry. Heater. Heater is what? Why? Why? Y2. Okay. But it is not sufficient. When it has to be stopped, the heater has to be stopped when it reaches this, okay, set point, that's all, okay. It works fine, but we have to include one more contact, that is stirrer has to be included, that is Y3, and it should be connected and yes, Y3 is connected. Now we have to wait for 5 minutes. We have to wait for 5 minutes. What are the conditions required? M0, the memory variable M0 is required. M0, okay. Then the tank must be full. X3 is required. Tank must be full. X3 is required. Then X4 is required. Because X4, it means the temperature is reached. That's why X4 is required. X4 1. So X4 is required. Once it becomes 1, the temperature is reached. Any other thing has to be included. That's why heater should be turned off. That's why Y2 bar. Y2 bar. Y2 bar. We can press function keys F1, F2, F3. Here, to press the function key, I have to press shift. That's why I am using this. There, if it is PC, you can use function keys. So, Y2, what is the heater? Y2, okay. Now, what is the output? Timer. That's all. Once the timer elapsed, it has to open the outlet valve. It has to open the outlet valve. For that, we have to include M0. All runs included with M0. Then, what is required? Oh, okay. What is required next? T0 will trigger the outlet. So, we have to use T0. If T0 becomes 1, it will start. Then that's all. But when the outlet valve has to close, it becomes empty. It becomes empty. Empty means 1. So we can include X2 as such. We can include X2 as such. Till then it should open. So X2 as such we can include. Is it okay? Yes. Okay, but problem is there. What is the outlet valve? Number? Y4. It will work, but the problem is this X3 means what? X3 means high level. That once the outlet valve is opened, it will drain. That's why T0 after some time T0 becomes 0. T0 becomes 0. So across T0 we have to put a sealing contact. So we will change this into T0 because we have to put a sealing contact. If it is in the beginning, it will be convenient. That's why we will make this as T0 and this will make it as M0. You need a sealing contact, M0. So here you need a sealing contact. Why? After some time T0 becomes 0 because here X3 is in series with T0. It won't be 1 forever. It will start, then after some time if it falls below that, the tank is not full. That's why X3 becomes 0. X3 becomes 0. That's why it will not work. That's why we have to include a sealing contact. That sealing contact is Y4. Y4 is the sealing contact. Y4 is the sealing contact. Y4 to keep it on. That's all. That's all about programming for the batch process. We have to verify this. We have to verify this by running this. We'll verify. Why sealing contact is required? X2 is what? X2 will be full means 0. When it has to open, full means it has to open. So it must be normally closed. Normally closed because when empty it becomes 1. When empty it becomes 1, outlet valve will be closed. When it becomes empty, it becomes 1, it becomes 0 here. Automatically it becomes 0 because that's why I put a NOT gate. So outlet valve will be closed. That's all. That's all about the program. Now we have to compile and verify this program, whether it is working or not. We will verify. Yeah, first, let us save this. Then we will compile. Compiled. Now we have to simulate. Run. It is in run mode. First thing, we have to turn on the program. Program is not functioning. That's why M0 is required. When everything is ready, then only we will turn on the program. If you turn on the PLC, the program should not work. That is our idea. If you press the start button, then only the batch process will start. So I am pressing the start button. So I am pressing the start button. Set on. Set off. But what is the status of empty is not 1. Empty is not 1. Empty must be 1, you know. The X2 must be 1. Where is X2? Because now it is empty, you know. That's why we have to set on. Y1 is turned on. It means inlet valve is open. After some time, what will happen to that proximity switch, lower proximity, bottom proximity switch? It becomes 0 because level will raise above that proximity switch. That's why it is not empty. That's why it becomes 1. It becomes 0. Am I correct or not? That way we have to simulate. Still, inlet valve is on. Once the level is reached, what will happen to X3? X3 becomes 1. Tank is full, X3 becomes 1. Anywhere you can change. Here I can change. Anywhere. Here or here you can set. Let us set here. I am set on. Tank. Heat is turned on now. Y2, Y3 is turned on. Now, X4 must be 1. X4 must be 1. It means temperature is reached. The transmitter will give 1. Now, X4 has to be 1. We are making set on. What happens here? After a delay, outlet value is opened now. Outlet value is opened. Now it is draining. We have to imagine like that. Now the tank is draining. First, what will happen? First X3 becomes 0. First X3 becomes 0. So we have to change that first. Still, the valve is open. It is functioning correctly. Still, the valve is open. Now, after some time, what will happen? It completely drained. Am I correct or not? Completely drained. Completely drained means what? X2 becomes 1. X2 becomes 1. X2 set on. Inlet valve is opened. Again and again it will do. Again and again. Drain, it will fill, heat, wait, drain. Fill, heat, drain, wait, drain. Repeatedly it will do. So this is called the batch programming. It works fine. So outlet valve is closed. Once it becomes empty, outlet valve is closed. The correct sequence of signal we have to give. Otherwise, you cannot verify the program. Okay. Let's let us stop here. So now take the third experiment. Turn on a lamp immediately when a push button is pressed. Turn off after 5 seconds when the stop button is pressed. What is the requirement?
Turn on and off immediately when the push button is pressed. Turn off after 5 seconds when the stop button.
So here you need only start and stop button. They are connected to X0 and X1, not X2. The output is connected to Y0. Shall we assume like that? The input diagram is like that. There is no, this part is not there. That's all. We have to write program for this. X0, X1 to turn on and to turn off. If you press X1, it will turn off the lamp after 5 seconds. That's all. This is the third experiment, third part. Turn on a lamp. Sorry, third. Turn a lamp on immediately. Turn on the lamp immediately when a push button is pressed, and turn off after 5 seconds when the stop push button is pressed. So that we have seen yesterday. Once again, you will see that. I think you may not understand that. So this you know. What is this? Turn on a lamp and turn off a lamp. Am I correct or not? So instead of M0, if you put Y0, you see that diagram. Instead of M0, if you put Y0, we can connect the lamp at Y0. So it will work as on off. So if you press the X0, lamp will be turned on. If you press X1, lamp will be turned off. This is good. It will work fine. But we don't want to turn off the lamp immediately. We want to turn off the lamp after 5 seconds. That's why what we can do is we can remove this X1. To understand, I am telling you. I'll little bit modify the program so that you can easily understand this. So then what will happen? You can turn on, you cannot turn off. You can turn on, but you cannot turn off. We need a provision to turn off. Now you think like that. This M0, if you connect M0, then if you put M0 here and Y0, M0 will turn on Y0. So the lamp will be turned on. So if you put here, if you put M0, in the end, if you put Y0, the lamp will be turned on, but it cannot turn off. You need a provision to turn off. Am I correct or not? So to turn off, we need a provision. That's why what we can do is, we are going to use two push button switches. One is X0, another one is X1. Both are normally open. So that we are using. Already we decided that. So we'll put a provision for turn off. For that, same type of setup we will create one more. That X0 is there. There we are including X1 to turn off. X1 to turn off. So here we are going to use another memory variable. Say M0. We are going to use M0. M1. Here we need a ceiling contact. M1. Yes. Now you can think like this. M1, if you connect M1 in series, it will turn on. M0 will turn on. M0 will turn on. M1 will turn off. Because X1 is with M1. M1 has to be used to turn off, but not immediately. So we have to use a timer. If you put M0 and M1, what will happen? Now we will put this way. I think now these two statements you understand. First, we can on. If you use M0, we can on, but you cannot off. In the second statement, both we can on and off. Both can be done, but immediately it will be turned off. If you put like this, here M0 in series with M1. If you connect both and Y0, if you turn on, it will be immediately turned on. If you turn off, immediately it will be turned off. You understand this? I am putting this way. I am temporarily writing. This is not required, but to understand, again we will include that. M0 in series with M1, lamp will be connected at Y0. So it will work. If you press X0, both are X0. So M1 as well as M0, both will be turned on. Both are in series, that's why Y0 will be turned on. Am I correct or not? If you press X1, M1 alone will be turned off. M1 will be turned off. And M1 is in series with that, that's why it will be turned off. If you press X1 immediately, but we want a delay. That's why we have to include a timer. So what we have to do is, we have to put M0 here. M naught. What is the purpose of M naught? Sorry, M1. M1 is turn off. M1 is to turn off. M1 is to turn off. So we are putting in series with that one timer we are going to use. The timer TM1. That's why it's not working. Timer. So we need timer 0 we are going to use. In that we are going to give time of some 25, because then only we can see, otherwise it will be very fast. That's why we cannot see. So 25 seconds. 2.5 seconds, I think so. Okay. Now we generated a timer. So instead of M1, we are going to use T0 to turn off. Turn on, which is required. M0 is required. So now we will put M0 is to turn on. That's why we are including M0 to turn on. M0 is to turn on. Will the timer works? If x0 equal to 1, m0 will be 1, because we are having a m0 as ceiling contact. That time m1 also 1. If you press x1, immediately m1 becomes 0. So we cannot use m1 to turn on the timer. If you press x1, m1 becomes immediately 0. That's why we cannot use m1 to turn on the timer. So we have to use M1 bar, not M1. Because when M1 becomes 0, then the timer has to be turned on. At the same time, it should not always turn on. We should understand that it is during the time of turning off. Turning off means this is turned off. At the same time, lamp should be glow. That time, if you press off, then only it should turn on the timer. That's why how we can understand that lamp is glowing. For that, M0 is required. So here we have to include M0. We have to include M0. M0 is to indicate that lamp is glowing. M1 is to indicate that you pressed stop button. You understand that? Both should be there. Lamp should be glowing. At the same time, we pressed stop. Both are indicated by M0 and M1. M1 indicates that lamp is glowing. M1 is indicating that lamp is glowing. M1 bar is indicating that you pressed stop button. So timer is turned on. Now use the timer and M0. If both are 1, we need M0. We need M0. Once I wrote, you will understand. M0. So lamp is, M0 is 1 means lamp should glow. At the same time, when it has turned off, when T0 comes, it should turn off. That's why till T0 comes, it should work. Therefore, T0 bar we have to use. We have to use T0 bar. So put a T0 bar. T0 bar. And you put Y0. That's all. So first line is, if you press X0, M0 is 1. If you press X0, M1 also 1. Both are 1. Both are 1. That's why M1 will be 0. That's why timer will not turn on. Timer will not turn on. The third line, second, third, fourth, fifth rung. That is the fifth rung. If you see that M1 bar, this is the fifth rung. M1 bar, M0. So M1 bar means it is 0 because M1 is 1. When lamp is glowing, M1 is 1. M0 also 1. That's why timer will not turn on. Timer will not turn on. If you come to the sixth rung, M0 is 1. What is T0? T0 is 0. Timer is not yet turned on. So T0 bar is 1. Both are 1 AND gate. If you connect in series AND. So that's why the lamp will glow. Let us save first, then compile. Compiled. Then simulator. Online mode. That will interface the PLC and this so that we can see what is status. X1 is 0, X0 also 0. That's why X1 bar is 1. X1 bar is 1. M1 bar is 1. T0 bar also 1. Lamp is not glowing. Now we have to run. Now it is in run mode. Now, if you press X0, lamp should turn on. If you press X0, so it is a toggle switch. That's why I will set on. Immediately I will set off also. Yes. So lamp is glowing. Lamp is glowing. Now let us turn off. For that we have to press X1. Am I correct? X1 we have to set on. Timer is starting. Timer is starting. Now it is turned off. After 25 count it is turned. But we have to set off also this. But again, there is a problem. What is that problem? What is that problem? M0 is still on. No problem. It is working. But because of the ceiling contact M0, this remains on. This remains on. So how we can remove that? To remove that, we can put this as Y0. Y0. To check, let us turn on one more time. What happens? Set on. It's working fine. Working fine. And we have to set off this. Set off this. But if you set this on, counter started. After 25, count, it stopped. It's working fine. But the ceiling contact is keep the M0 always on. The ceiling contact keeping the M0 always on. But because of T0, it is not working. Because of T0, it is not working. So it's not correct. So to make it correct, let us convert this into Y0. Be Y0. If you put Y0, it works fine. So let us stop. Let us put Y0. I made Y naught. Now let us make save, compile, simulator. Okay. Now let us run. Now let us check. Set on, the lamp is turned on. Set off, still the lamp is on. So I press the push button X0, it is working fine. Let us check X1. Set on, still it is working. It's working fine. At the same time, the ceiling contact also not in on state. So these type of bugs, it may not give error while functioning. We should not leave as such, because in a larger program, it may lead to some other problem. That's why we have to correct all these things. Why, if you put Y naught, it is not on? Why? What is M naught and Y naught? M naught is to keep on. M1 is to off. Am I correct or not? M naught is to keep on. M1 is to keep off. If you put M1, immediately it turns off. That's why it is not working. So we should not use M1 anywhere, because M1 is to off. M1 is to off immediately. That's why we should not use it as a ceiling contact. But if you put Y naught, it is working, because Y naught we are keeping on by using M naught. We are keeping on. But if the time after timer, it becomes 0 automatically, Y naught also. That's why in the ceiling contact, instead of M naught, we have to use Y naught. Do you understand this? Next experiment is turning on the first motor. Note down. Take down. Turning on the first motor by push button, which pumps oil immediately. First part. Turn on the main motor after a delay of 10 seconds. Turn on the auxiliary motor, then turn on the auxiliary motor after a further delay of how much delay? Total delay. Once again, I am reading. Turn on the first motor by push button, which pumps oil immediately. That should be, first motor should be turned on immediately. Let us connect the first motor at Y naught. Y naught should be turned on immediately. Turn on the main motor that is connected to Y1 after a delay of 10 seconds. Then after that turn on the auxiliary motor after further delay. Further delay means totally 15 seconds delay. Totally after that, further delay of 5 seconds means totally 15 seconds delay. Turn on the auxiliary motor. So 3 motors has to be turned on. First motor is connected at Y naught, that is immediately turned on. Second motor connected at Y1, that is turned on after 10 seconds. Third motor connected it to Y2, that will be turned on after 15 seconds. Because there is a further delay of 5 seconds, means total delay is 15 seconds. And all the motors simultaneously by pressing the stop button. If you press the stop button, all motors should be turned off. So that way we have to write the program. So we are using X0, normally open switch, to turn on the motors. X1 is to turn off the motors. So same setup we are going to use. That is, you may not remember. This is, so 2 push buttons are there. One push button is connected at X0, another one connected at X1. X0 is to start, X0 is to start, X0 is to start. This is for start, this is to stop. This is to stop. Normally open. Normally open. Both will give 0. When it is open, they will give 0. Here, why Y0 M1, Y1 M2, Y2 M3. So 3 motors will be connected. Let us take a new file. Test 6. Now, first motor has to be turned on immediately. Therefore, we have to put X0 start. To stop, we need X1. X1 is normally closed. This is normally closed contact. This is normally closed contact. We are using normally open switch. That is called, the hardware is called switch. The software here, what we mentioned is called contact. Normally open contact for X0, normally closed contact for X1. We are using, and we are going to connect Y0 directly. Y0 is to turn on the first motor. That's all. So we need a ceiling contact. Let us put Y0. So let us put a ceiling contact. Y0. Y0 is used. That's all. 2 runs over. This will turn on and off. Immediate on, immediate off of Y0. But we need one more motor that will be connected at Y1. That has to be turned on after 10 seconds. So what we have to do is, we have to use a timer. For that, we can use Y0 itself. Y0 is output as well as memory variable. It is available in the memory output image table. That's why Y0 can be used as memory. That's why we can use here a contact Y0, Y0, Y0 to turn on a motor 2 that is to be connected at Y1. For that, we need a timer. The timer, its name is 0. Delay is 10 seconds. Yes. Okay. This timer will be used to turn on the second motor. So we have to use a timer here. Timer has to be used to turn on the motor. Because after 10 seconds only, the timer output will becomes 1. That will be used to turn on the second motor. That is Y1. So second motor will be turned on after a delay of 10 seconds. Then the third motor has to be turned on after 5 seconds with a further delay of 5 seconds. Further means 10 plus 5, 15. So instead of using Y0, if you use Y1, there will be another 10 seconds delay. So we can use Y1, that is already 10 seconds delay. Now we'll use Y1 that gives 10 seconds delay. That Y1 gives 10 seconds delay. We need another 5 seconds delay, further delay. So timer that need 5 seconds delay. The same name we cannot use. That's why we'll make it 1. And here the delay is 5 seconds. Let us put again 10 seconds. Here in the sum it is 5. Let us put again 10 to see. That's all. So now T1 will turn on the third motor. T1 will turn on the third motor. So we have to use T1 to turn on the third motor. So here yes, third motor means first, second, third. Y2. That's all. So now we can save this. Compile this. Then simulator. Compiling is complete. That command should come. Otherwise, you are having some errors. Then online mode. Yes. It is in run mode. In the PLC, there is a switch to run the program. That is called run mode. There is a switch to turn on as well as to keep this in run mode. If you keep this in programming mode, you can upload your program. That and all you will learn in the lab. While uploading a program, it should not be in run mode. While the uploaded program has to run means you should keep that in run mode. Yes, the program is ready to run. Now let us simulate. This Y0 should turn on immediately. Let us check. Set on. Yes, it is immediately turned on. After 10 seconds, Y1. After another 10 seconds, Y2 turned off. So we will keep this set off. If we give some 50, 100, then we can easily watch. Because here we are not having the push button. Instead, we are having a toggle switch. That's why we have to turn on and off. It takes time. That's why we cannot notice. But anyhow, better you give 100, 100. So, or 50, 50. You can watch. Then let us check whether it is all turned off immediately. Let us check. Set on. Yes, all turned off immediately. All turned off immediately. If you turn on, not all turned on immediately. One by one, it is turned on. Notice that? Yes. One by one, it is turned on. Set off. If you turn off, all will be turned off. Sorry. If you turn off, set on, it will turn off, all turned off immediately. Set on means you are pressing the push button. Set off means you are releasing the push button. Set on means in simulation, set on means you are pressing the push button. Set off means you are releasing the push button. That's all. The first experiment is over. Small programs. Programming a PLC for lamp control using single push button. That is working like a toggle switch. It is working like a toggle switch. If you press once, lamp will be turned on. If you press once again the same push button, the lamp has to stop. Turn off. So for that, we have to write the program. What is the difference between the ladder logic diagram using relays and PLC is? Relays are working, all runs are working simultaneously. All runs are working simultaneously. For example, here I am having X0 and X1 is connected. Let us assume here one relay is there. Here also one relay is there. This is Y0, this is Y1. The difference between this is wire-wound relay logic means, suppose X0 and X1 are simultaneously become one means Y0 and Y1 become simultaneously one. Y0, Y1 will be turned on simultaneously. But in ladder logic diagram using PLC, first Y0 will be turned on, then Y1 will be turned on, because it is nothing but a sequential program. Nothing but a sequential program. But what is the difference in turning on of Y0 and Y1? It will be in microseconds. How long it will take to execute the first line, first run? To execute first rung, it may take 10 microseconds. Let us assume that. Immediately after 10 microseconds, this Y1 will be executed. That is the difference. Definitely there will be a delay between Y0 and Y1 if you use PLC program. But if you use wire wound, all will be simultaneously turned on. This is true in the case of HDL programming. You are writing Verilog or VHDL program means you are writing program for IC means in a hardware, if all signals come simultaneously, the IC will work simultaneously. But in simulation, it will be sequential. For that, in simulation, some restrictions will be made. Till all checking all signals, it will be executed like that. The compiler will be made. But anyhow, while doing simulation, you should be very careful. In the same way, here also, R1, R2 will be executed sequentially. That sequential can be used to turn on the lamp, turn off the lamp by using single push button. That we are going to use. For that, the first rung consists of the first rung is one push button is connected at X0. Push button is connected at X0. Then output Y2 is normally closed and Y1 is normally open. Then Y0. Then here in the second rung, X0 is there. Second rung also X0 is there. X0 is the input. Here, here Y2 normally closed. Y0 also normally closed. And Y1. Then the third rung is again, it consists of X0 and Y2. Let us assume that the lamp is connected at Y1. Lamp is connected at Y1. At Y1, lamp is connected. Y0 and Y2 can be, you can use memory variable, M0, M1. You can use, no problem. Because we are going to use only Y1. We are going to use only Y1. This will, if you press X0 once, now what is the hardware diagram? Hardware diagram is like this. This is input module, PLC. This is output module. Y1, at Y1, lamp is connected. Lamp is connected. This is neutral. This is 230 volt. At Y1, 230 volt is available. Now, at X0 is a push button is connected. X0, a push button is connected. This, if you press once, plus 5 volt. If you press once, the lamp will be turned on. Again, if you press turn, lamp will be turned off. Let us check. Initially, what is normally open, X0 is 0. X0 0 means X0 is in all rungs. That's why Y0, Y1, Y2 all are off. Am I correct or not? Because X0 is in series with all rungs. Initially, X0 is open. That's why Y0, Y1, Y2 all are 0. Now, the push button is pressed. Push button is pressed. That's why the first rung will be executed first. R1 will be executed first, then R2 will be executed, then R3 will be executed. Because sequential program. PLC is sequential. First, this will be executed. X0 is equal to 1. Y2 is already, we have seen that Y2 is off. That is also 1. Y1 is not yet turned on because sequential. Now the first rung only executed. Being executed. Second rung not yet executed. That's why Y1 is 0 initially. y2 also 0, y2 also 0. That's why this is equal to 0. This is equal to 1. x0 1, y2 1, but y1 is equal to 0. That's why this is equal to 0. Next rung will be immediately executed. What is the value of x0? How? It is push button. You released, no? But the push button, the world average for a push button to pressing a key is 30 milliseconds. How much? World average is 30 milliseconds. If you press a key in a keyboard, the keyboard will be closed for 30 milliseconds. World average. So it will be closed for 30 milliseconds. During that 30 milliseconds, let us assume that this program will be executed 30 times. Let us assume that to execute one time the program, 1 millisecond. To execute the entire program, how much time? 1 millisecond. How long you are pressing the key? 30 milliseconds. Therefore, while executing second rung, the still x0 is 1. Still x0 is 1. While executing second rung, x0 is 1. Therefore, x0 equal to 1. x0 equal to 1. x0 equal to 1. What is y2? y2 is not yet executed. Therefore, that is 1. y2 bar, that's why that is also 1. Here, y0 is not executed while executing in the previous time. It remains 0. That's why this is also equal to 1. Therefore, y1 becomes 1. y1 becomes 1. Lamp turned on. Now, which line will be executed? Third rung will be executed. Still, the key is pressing. We are pressing the key because 30 milliseconds. Let us assume that during that time, the program will be executed 30 times. Because to execute the entire program, it takes 1 millisecond only. So third time here also x0 equal to 1. x0 equal to 1. Therefore, y2 becomes 1. y2 becomes 1. How many times it will be executed? During pressing that push button, 30 times. Second time it will be executed. Second time you come here, x0 equal to 1, y2 equal to, y2 now it becomes 0 because just now it is executed, third run. y1 is 1, that's why this is also 1. But this becomes 0, that's why again it remains 0 only. Second run, if you come, x0 is 1. Out of 30 times, only second time now. x0 is 1. y2 is 1. That's why this is y2 is 1. That's why. Oh, ceiling contact I didn't put. Sorry. We have to put a ceiling contact. y1. Because of the ceiling contact, it remains 1. This is fourth run, R4. That is x0. This is y2. Now, because of the ceiling contact, even though y2 becomes 0, this will be executed because y0 is not yet turned on. This is 1 only. y0 bar is 1. That's why it remains 1 because of the ceiling contact. Next run, y0 equal to 1 only. y2 equal to 1 only because still we are pressing the push button. Third time it is executing. x0 equal to 1. y2 equal to 0. That's why first line will not be executed. Second line, because of ceiling contact, it will be 1. Third line remains 1. How many times this will repeat? 30 times. 31st time, 31st time, x0 becomes 0. Am I correct or not? x0 becomes 0. 31st time, x0 becomes 0. x0 becomes 0. y2, already it is 1 only. It is not yet executed. Second rung, third rung, fourth rung, not yet executed. That's why it remains 0 only. y1, it is 1. But that's why again y0 is 0 only. y0 is 0 only. Come to second line, x0 is 0. But y2 is Y2 bar, Y2 is 1 only, that's why this is remains 0. Y1 is not yet executed, remains 0, that's why Y0 bar is 1. So still the lamp is glowing. Even though I released the push button, it is glowing, lamp is glowing. Come to fourth rung, X0, now this becomes 0. Now this becomes 0 because I released the push button after 30 milliseconds. That's why this becomes 0. 31st time it is executed, Y1 remains 1, but Y0 is 0, Y2 is also 0. Now come to again first rung, X0 is 0, Y2 becomes Y2 bar, that's why this becomes 1. This becomes 1. Y2 bar becomes 1. Y1, this is 1, but this is 0. That's why it remains 0 only. It remains 0 only. Second rung, because of ceiling contact and Y0 bar, it remains 1 only. Y1, second time. 32nd time. Y0, X0 equal to 0. Therefore, this rung also Y2 equal to 0 only. This will repeat up to as long as you didn't press that push button, it will be remain on. Y1 will be remains on. Am I correct or not? Y1 will be remains on. Now I am pressing again that X0. Let us assume that now I am pressing again X0. Let us remove all values so that there won't be any confusion. What is Y0? Value of Y0? 0 only. Y1 1. Y2 equal to 0. Y2 equal to 0. Y2 equal to 0. That time I am pressing. What is the condition now? Y1 is 1. Y0 is 0. Y2 is 0. During that condition, I am pressing X0. I am pressing X0. I am pressing X0. That is X0 equal to 1. Already Y2 bar is 1. Y1 is 1. X1 is 1. That's why Y0 becomes 1 now. Y0 becomes 1 now. Second time, if you press the push button, Y0 becomes 1. Am I correct or not? Now the first rung is executed. How long I will press the push button? 30 milliseconds. How many times the program will be executed? 30 times. We are assuming that to execute the entire program, it takes only 1 millisecond. Definitely, executing all rungs will be less than the pressing push button. Because only 3 rungs, not in thousands of rung means you have to think about it. Here only 3 rungs. So here Y0 equal to 1. Now come to second line. Here it is a ceiling contact. That's why these first 2 contacts we need not bother. This is Y1 equal to 1. Y0, what happens to Y0? Y0 equal to 1 now. That's why Y0 bar equal to 0. Y0 bar equal to 0. That's why this is Y1 becomes 0. Now lamp is turned off. While executing second rung, the lamp becomes 0. That's why the ceiling contact also becomes 0. And if you come to third line, what is you are pressing, still pressing. That's why Y2 equal to 1. Y2 equal to 1. Now only one time executed. Second time if you execute, X0 equal to 1. What is Y2? Y2 equal to 0. That's why Y2 bar equal to 1. Y1 is turned on. That's why this turned off. That's why this becomes 0. That's why Y0 equal to 0. Y0 equal to 0 now. Y0 becomes 0 because Y1 equal to 0. If you come here, X1 equal to 1. This is ceiling contact is already 0. Y2 is 0. That's why this is 1. This is 1. Y0 is 0. That's why it becomes 1. What is Y2? Y2 is 1. That's why this is 0. X0 is 1, but Y2 bar is 0. Y0 is 1. Y0 is just now it becomes 0. That's why this becomes 1. Therefore, it remains off only. It remains on only because of Y2. Because of Y2, it remains off only. If you execute third run, it remains on. How many times it will be? Y2 will be remains on 30 times. The again and again, if you come, the Y0 will not turn on. I am released the finger. After 30 milliseconds, it remains off only. If you press again, the first case, again it will be turned on. Again it will be turned on. If you press again, it will be turned off. Let us check whether it is working or not. First thing is X0. X0. Then Y2 bar. Then Y1 bar. Y1, sorry. Then Y0. Second rung X0. Then Y2 bar. Then Y0 bar. Y0 bar, then Y1. Lamp is connected to Y1. Then we have to put a ceiling contact, that is Y1. Ceiling contact across X0 and Y2 bar. Then X0. Y2. Compile. So all Y0, Y1, Y2 are off. So we press X0 once, set and reset. Y1 is on still. One time I executed. Second time if I execute, set on, set off, all turned off. So this is working fine. If you press once, turned on, and if you press again, it is turned off. So by using single push button, we can write the same by using some other means. Need not be in the same way. It is to understand how a PLC working. It is working sequentially. We should keep this in mind. Then only we won't do any mistake in future. That concept we should understand. That's why we wrote this program.